Hello, today I'm going to talk to you about rational and irrational numbers. So we have a little diagram set up here. We're going to go through the rational numbers first. All right. So rational numbers, I'm going to list different categories and give you some examples. So one type of rational number is whole numbers. So that can be positive or negative whole numbers. So I'll just give you some examples. So -1 or positive 5,000, they're both rational numbers. So because our perfect square roots simplify to whole numbers, they're also considered rational. And I'll give you some examples of those. Something like the square root of 25 or the square root of 100. Anything that's a square root that simplifies to a whole number, that is rational. Our next category is fractions. So that can be positive or negative fractions. So something like -1/2 or positive 2/3. They are rational. We have two more categories. The next one is called a terminating decimal. Now, a terminating decimal, if you listen to that word terminating means end. So these decimals have an end to them. So I'll give you some examples. Something like 0.5. 0.5 ends, doesn't go any further than the 0.5. Or something like 3.62 has an ending to it. That is a terminating decimal. Now, the last category is called a repeating decimal. So a repeating decimal, I'll give you some examples, would be something like 0.333, where the 3 keeps repeating. And you notice on my last 3, I put a line over the last number. That indicates that that number continues off into infinity. So that is a repeating decimal. It has a pattern. I'll give you another example of a repeating decimal. Something like 5.1212. And I'm going to put my repeating line over the 1, 2. That pattern is repeating 1, 2, 1, 2, 1, 2 out into infinity. So that means that's called a repeating decimal. Okay? So those are your examples of rational numbers. So let's look at our examples of irrational numbers. All right, first we have our non-perfect square roots. So those are the square roots that sometimes we estimate. So like the square root of 2, or the square root of 3, or the square root of 5, or could be the square root of 99. So those are all irrational. And then our other category is a non-terminating decimal. I'll show you what that is. So this is a non-terminating decimal. Now, a non-terminating decimal continues off into infinity. So it looks like this. So I'm just going to put an example. Dot, dot, dot. That dot, dot, dot means that it's going to continue off into infinity, but it does not have a repeating pattern. It's a random sequence of numbers that continue. Probably the most recognizable non-terminating decimal is what we know as pi. We know that pi doesn't have an end and it doesn't have a repeating pattern. We think of it as 3.14, but it continues off into infinity without a repeating pattern. So pi is considered irrational. So those are our two different categories. I got one more thing to add here in the middle. So rational numbers and irrational numbers are both known as real numbers. Okay, so that's the overlapping. They're both under a category called real numbers. And yes, there are imaginary numbers as we get further on into math levels. But for now, real numbers are rational and irrational. And you have your two different categories and some examples of each. Thank you very much.